Welcome to Operating Systems Unit 7, Part 1. Today we're going to talk about interprocess communication. Processes that work in a system can either be independent or cooperating. Independent means that they don't interact with any other processes, and cooperating means that they do interact with other processes. Obviously, there are benefits to having cooperating processes. You can speed up computations and share information, and the two basic ways that processes communicate are either by sharing memory or passing messages. So if you take a look at these figures, figure A shows message passing, and in message passing this was a problem with the microkernel because each time messages are passed using send and receive primitives, the operating system needs to get involved in all of the management of this message passing. In shared memory, you have two very isolated processes, and the operating system decides to remove this restriction of allowing processes to access the same memory space, and you either have this area of shared memory that belongs to one of the processes or belongs to the operating system, but either way, both processes more than one process is accessing a memory space when the idea is to keep processes separated. So you can either use one of these two models in your system, and today we're going to talk about different ways in which messages are handled and managed by the operating system. In shared memory, it's very straightforward. There's just a shared area of memory, and in the second part of this section we will talk about threads, and threads by default share memory. Okay, so messages. When you're using message passing, you have send the message and receive the message. But there are some things that need to be considered about how messages are sent and received. Do you have a unidirectional link, meaning the message only goes in one direction? Do you have a bidirectional link where the messages have to go in both directions? Do the processes have to wait for each other to get the messages? Do the messages go directly from one process to another, or do the messages go through a mailbox? So today we're going to talk about not the physical way that the messages are passed between processes, but the logical way in which they're passed between processes. Okay, so how do the links get established? Do more than two processes share a link? Do more than two processes communicate? What is the capacity of the link? Do you have, is the links in unidirectional or bidirectional? These are some of the questions that need to be answered when you are setting up and planning to do message passing in the system. So the first thing we'll talk about is direct communication. Direct communication means that the processes communicate with each other and only two processes are involved, and the process will make the operating system will set up the link between the processes, and then they will communicate without using a mailbox or a buffer or anything else. They will just communicate directly with each other. So the link is associated with exactly one pair of processes. Between each pair, there's only one link, and the link may be, and usually is, bidirectional, meaning the communication can go in both directions, but it may only go in one direction. And again, this is just a logical concept of how communication links are set up in operating systems. The next is indirect communication. So indirect communication means that a mailbox or an area of shared buffer can be used to place the messages into. And sometimes these are called mailboxes or ports, and each mailbox has a unique identifier, and the processes must be able to access these mailboxes in order to get the data. So the link is established if the processes share this common mailbox, and the link may be associated with many processes, and each pair of processes may share several communication links. And it may go in one direction or it may go in more than one direction. So all we did here was discuss that in communication, processes can either communicate directly to each other or they can communicate through a mailbox or a port or an area where the messages are stored rather than directly. So to synchronize the messaging, there are different ways in which they can be synchronized. Remember that you have send and received primitives. So you can either synchronize by having the processes block while sending, block to receive, or non-blocking. Non-blocking is asynchronous, which means that the process doesn't need to wait to receive the message or wait to make sure that the message has been received, where in blocking the process must wait to make sure the message has been sent or must block to receive the message. So again, there's the blocking send, means that the sender blocks until it has made sure that the message has been received, and a blocking receive means that the receiver blocks until it makes sure that the message is available. That means that's synchronous. It means that the processes cannot continue working until that they know that the messages have been sent or received. And you can have just a blocking send or just a blocking receive, or you can have a blocking send and a blocking receive, which is called a rendezvous. A non-blocking, which is asynchronous, means that the sender sends the message but just continues and doesn't need to know that it's been received in order to continue working. And a non-blocking receive also means that whenever the receiver is ready to pick up the message, they will pick it up, but it's not going to interrupt their current flow of execution just because they have to wait to receive this message. So we've discussed the terms direct communication, indirect communication, and synchronization of communication. Synchronization can apply in direct, meaning you have a rendezvous or a blocking send and receive directly between processes, or synchronization can apply, meaning you have to make sure that the process that's receiving from the mailbox has received from the mailbox, or that the process that is sending to the mailbox has sent to the mailbox, and those can be blocking and non-blocking as well. And just to go over, because we're in next section, we're going to start talking about synchronization. One situation is producers and consumers. So a producer will produce and a consumer will consume. So there's a problem with buffers, because a producer can only produce into a buffer that has empty slots in it, and a consumer can only consume from a buffer that has something in it. So this starts on this idea of cooperating processes, and there are some issues about this bounded buffer problem, because what happens if the buffer is full and there are no more places to place information? And what if, so you can say, all right, then we'll just use an unbounded buffer. But you can't, systems cannot use an unbounded buffer, because an unbounded buffer indicates that there's unlimited resources, and that's not the case. In systems, there is a limit to the amount of resources that are available. So there's some things that need to be taken into consideration about a buffering of your messages. And like I just said before, if you have a send and receive where the sender must wait and the receiver must wait, you have what's called a rendezvous, and that's a zero capacity buffer. And if you have a buffer that has a finite length, then the sender must wait, because the sender will then be forced to block, because the sender cannot place any more into the buffer. And if you have an unbounded capacity buffer, then that means that the sender will never wait, but you cannot exhaust the resources in your system. So thank you very much, and the next section of this unit we'll talk about threads, and then starting in Unit 8 we will start getting on to synchronization.